Welcome everybody to the meeting. This is our first meeting of 2022. We had hoped to be having some meetings in person shortly, but I don't think we will just now. The February meeting was intended to be a meeting at the Teesside University at their Digital Innovation Centre, but we've decided to make it another WebEx meeting like this one. So I'll be announcing what the subject of that is in the next newsletter, because at the moment I'm not quite sure. Things are still a bit up in the air, I'm afraid. I would like, however, to plug the Young Persons Lecture competition, which is on March the 2nd, Wednesday, March the 2nd. I have sent details round in the newsletters, but if anybody would like to get further particulars from me, then please drop me an email and I'll be happy to send you the rules and the information. By young, that means less than 28 on June the 1st this year. So if anybody has any association with any suitable young persons, I'd be delighted if you could persuade them to express an interest. Right. I'm just looking at my crib sheet. I think probably the next best thing to do is to hand over the reins to Mark. I'm just trying to find him. Here we are, and I'll hand you the presenter's role. If you'd like to share your screen with us, and I'd better unmute you as well, hadn't you? That might be a good idea. Ah, you are unmuted. So over to you, Mark.
Thank you very much, Sue. Evening, everybody. Can you see that? It's coming up now. Brilliant. Excellent. So thank you very much, first of all, for turning out from the comfort of your front rooms or wherever you are. As Sue says, it's a shame we can't actually be in person, because particularly talking about new areas like this, the most interesting discussions are when we actually chat to each other afterwards and get questions going around. So with that in mind, I'll try not to take up too much time talking, but I wanted to give a perspective on hydrogen in the metal sector, kind of from how I see it in my role as manager at the Industrial Decarbonisation Group. So within the Materials Processing Institute, I'll explain in a while, but we have a few different sort of research and activity groups, and my background is in materials chemistry, and then in renewable energy, and then in other sort of diverse project management. So I want to give a bit of context to start with, really, because to understand somebody's perspective, you have to get a bit of the context of what's going on, and then just talk through some of the kind of the two aspects really of hydrogen. There's a lot of talk about hydrogen in the news. My Google feed thing pings me hydrogen news every day now, because it's obviously worked out that I'm interested in it. And it's one of those fast-moving areas where, obviously, if you start searching on it and reading on it, you'll get something new pops up almost every day at the moment about either people announcing investment plans or new bits of technology, or could this be the future, or occasionally some slightly more questioning and critical looks at the realities of the hydrogen economy currently and the way that it's heading. There we go. So to put us in context, here we are, a view from the Materials Processing Institute, right up in the heart of Teesside. There we go. If you're I'm sure you all know who we are. If you want some historic context there, we're Teesside Labs is our origin story, where we've evolved from. But today we are engaged in really all the challenges of helping to support the transition of UK industry and other partners around the world to the low carbon, circular, connected, intelligent economy that we all hope for, that will enable ourselves and our children and grandchildren to continue living something recognizable on this planet. So I'm just going to nip back a little bit first, because I wanted to start with that, because part of the context of talking around hydrogen, and the reason it's exciting, and one of the big reasons that we're getting involved in active projects around hydrogen and the metals and other foundation industry sectors, is because Teesside produces at least half of the UK's hydrogen currently anyway, and has done for decades. And there's a huge concentration of expertise, experience, and I suppose you could say comfort level as well. It's one of those areas where if you have not worked in it before, or you mention, oh, we're doing this, that, and the other with hydrogen, safety concerns are one of the first things that pop up. And whilst it's obviously is a very mobile, very leaky, and very combustible gas, it's also a substance that, particularly in this part of the country, there is a wealth of experience of handling, safely containing, transporting, and using it, as well as generating the stuff. So the context is important too, because we are looking, the future is all about green hydrogen. If we have any, and the best placed parts of the country to be really forging ahead and showing leadership in production of green hydrogen are those near large renewable energy resources. So I've got the Redcar coastline up there. If I zoom in on my picture of this screen, I can just about see some little dots, which I think is Google Earth's attempts to take a picture of the edge of the Redcar sort of near offshore wind farm cluster there, which is really just the beginning of the push out into that whole area of North Sea shelf for offshore wind generation. Having said that, of course, there's also significant investment and plans announced for expanding hydrogen networks, for investing in hydrogen for transport in the area, as well as plans coming and announced for green hydrogen production to start adding electrolysis to Teesside's kind of basket of tools for producing industrial gases. So all in all, good place to be if you are really into hydrogen. But to expand the context for ourselves as the Materials Processing Institute, because I want to talk about transition and development, this kind of transition and disruption elements of introducing essentially a new energy vector, or certainly an energy vector that's only had a specific set of uses in either chemical or heat production before. This is actually something we encounter in almost every aspect we work in, because part of the Institute's work is in new materials development and new process development. Part of it is in industrial decarbonisation, which is my team looking at that, and that ranges from efficiency measures through to sort of transformative fuel switching and so on, and also incorporates embedded generation, where you're actually producing your own power from renewable resources, or even in some cases looking at how that would work to integrate the use of renewable electricity from wherever to produce hydrogen on site to use within a mill or a factory or a iron production unit or something. I'll get onto those in a moment. But we also the change and disruption around manufacturing and materials processing expands to the vision for the future where we have a circular and lower energy economy, where there is much more reuse and continuous cycling of materials. And again, that obviously poses different sets of challenges to us as scientists, engineers, and business development people, really, in how the thinking has to change and become more joined up in terms of how just the way we think about materials we process and use. And that's all underpinned by the digital revolution, obviously, without which we wouldn't be chatting to each other in our front rooms through the screen. But that there's an awful lot of fast-moving disruption, even though we're familiar with computers now and everything. Still lots of disruptive technologies coming along, whether that's to do with actually controlling energy production or the flows of energy markets, trading markets as well. So all of this kind of sets the context for where we're going. I mean, we are engaged in working in materials development from the small and disruptive, like 3D additive printing, to the more traditional, more recognizable melting and casting facilities we've got there. But even that, we have to look at ways of decarbonizing those elements of steelmaking. We have digitization and enhanced controls and ways of visualizing things and ways of communicating with folks when we are building new furnaces. The furnaces we plan to install over the next year to 2 years at the Institute will be interesting from the point of view of being largely centered around hydrogen as the heat source, or as the reductant source. But also we plan to create digital twins so they can be visualized remotely. We can show researchers, customers, interested parties and stakeholders actually what's going on, without everybody having to be clustered around. Having said that, at the end of the day, there is nothing quite beats being clustered around hot metal and actually making things with it, because that is, you can't build your entire life on online on software. But the impact of hydrogen's potential invasion as an energy source, and the levels of research, development, and understanding, communication, education that needs to follow it goes from, as in these pictures, goes from the macro level right down to the micro level. There is a wealth of information and published papers and communication that's gone on so far around the trials and pilots and potential for use of hydrogen in anything from large scale reheating down to, so what are the atomic level reactions going on for metals reduction. But there is, anybody with an inquiring mind knows, the more information you gather, the more questions you have. So I'm leading up to start talking about hydrogen soon, but the context for that picture of Teesside Beam Mill was some work we did earlier this year, last year actually, 2021, looking at some of the potential sort of heat recovery options within that mill, and that is bang in the middle of this kind of spectrum of stuff we have to look at in decarbonisation, moving from sort of energy efficiency and improved process controls right through to fuel switching. But one of the obvious questions for large heating mills like that is, if you have to decarbonise and your customers are starting to push you for a green product, something they can label as green steel in their buildings or in their cars or their tin cans or their whatever they want to make with it, really. Nuts and bolts. Then you are in good company, because most of the manufacturing sector now is starting to feel this pull from the customer base to decarbonize, as well as the push from government announcement of UK's net zero ambitions. You know, we may be a little bit ahead, a little bit behind of others in terms of where we're setting the targets, but it's a trend across the developed economies of the world, really, to recognize the need for what I've got here is the first main bullet point. The need for significant carbon dioxide reductions as early as possible in order to start to bring the curve of the global CO2 levels, start to curb it and bring it into a flatter line. So in terms of hydrogen in metals processing, what we are trying to focus on really is appropriate applications of it. You can burn it, but do you need to burn it? Because if you are trying to use electricity to produce hydrogen, and then you burn it again to produce heat, at what point does it make more sense to be using hydrogen for a combustion heat source? At what point would you be better off really looking at the whole life cycle, transitioning to electric heating? And that depends on your process, depends on the materials you're putting through it, obviously, depends on the temperatures you're trying to reach. But the appropriateness is going to be one of those factors that starts to impact the market. There will be, over the next decade, demand for hydrogen and customer demand for green hydrogen. And I won't go into the hydrogen color matrix unless you ask me to later, but it's but by green hydrogen, I'm basically referring to hydrogen produced through renewables or with a net zero carbon footprint. And I'm not referring to blue hydrogen in this context, but the organizations and bodies which will certify a product as green steel or green aluminium or green plastics or whatever are going to be scrutinizing the life cycle of the whole process, and in order to retain credibility and to really develop their reputation so they become used as a standard mark, will need to be seen to be have integrity in the way that they assess the overall impact of these technologies and these products on global CO2 levels. It won't be, I don't think, acceptable really for very long for companies to have in-house green labeling without being able to back that up with some independent verifications and publish their working, really, and publish why are you labeling this as green. I think the general public, who ultimately do create the pull for most of the customer demand for lower carbon products, are becoming more educated in the differentiation of sort of greenwashing or actually genuinely sustainable transformative production. And as I say, a lot of the choice in terms of heating, particularly, is between electrification or using hydrogen directly as the energy vector. We'll come back onto hydrogen and combustion and heating in a moment. But there's also the issues of supply, as I say, demand. Already, even for us trying to put some small hydrogen burners into our melt shop, and looking ahead at creating sort of pilot units for green iron reduction with hydrogen. Already we're talking to the hydrogen suppliers. Of course, they want to be in at the ground level of some of this work, because it's going to be very beneficial, really, to be engaged at this stage in the development of these kind of technologies. But even talking to them now, if we want to secure supplies of hydrogen, we've got to get our foot in the door, even for quite small amounts, because the growing interest in innovation and R&D and pilot projects around how does a hydrogen economy develop is already starting to the demand is already starting to outstrip the likelihood of supply for this year, for certain. And I think that's part of what's starting to build the momentum for all these investment announcements you see in hydrogen and green electrolysis and electrolyzers and so on, because handling and transport of this stuff is not it's not rocket science in that sense, but it's not quite as straightforward as LPG. There's just an order of magnitude of pressure and compression or cooling that's needed, or other matrices to keep the hydrogen stable. And the other general picture thing, which is what kind of initially attracted me into the sort of the world of hydrogen, if you like, is the way that electricity as the initial energy vector, and let's assume that is greening itself and is becoming much less carbon intensive as wind, solar, hydro, wave power, etc., penetrates the national grid more, and the higher intensity carbon sources are taken off our grid. You can produce hydrogen anywhere that you've got electricity and water. It's not obviously quite that simple to do it in large scale economically. Hence the reason that last year the price of electrolytic green hydrogen was around about 3 or 4 times the price of sort of standard steam reformed grey hydrogen. Interestingly, with the big fluctuations and the sort of basically permanent gas price hike that we've experienced over the last 6 months plus, that price differential has changed quite a lot. And as you know, power markets in general are not just based on a materials extraction cost. There's all sorts of other elements and market controls and trading systems and so on involved in what's actually the spot price of various energy sources. So the differentiation in prices is becoming less clear, but still it's still ballpark more expensive to make hydrogen electrolytically on site. But for the first time in your lifetime, unless you used to go out and gather wood or dig coal out of the ground and get your coal allowance in a sack, you've actually got energy production on your doorstep again. You can actually produce a storable energy vector that can be used, compressed, deployed, dispatched as and when you need it, if you want to, if you have the ambition, the wherewithal, and the budget. So you're no longer necessarily dependent on national grids for distribution. You can produce the stuff on site. You can produce it right next to your process. You can make it, compress it, handle it. I'm not saying many people are doing that currently. And certainly in terms of large scale storage on industrial sites, that's not a common phenomenon quite yet. But that's part of the disruptive aspect of a move to the hydrogen economy, is this the fact that distributed generation, someone up on a mountain with a solar panel and some electrodes and some water can make hydrogen, whereas they're never going to get gas pumped up there. They may, and it's probably a few hundred years since they cut all the trees down for wood to supply fuel. It changes the map. It changes the landscape a bit. Right. I'll try and speed up so we've got time for some chats and questions. The transitional aspect of hydrogen in metals processing, I'll try and concentrate on that, is really as in the area of gas heating. There's ambitions. The target sort of moves back a little bit here and there, but there's ambitions and aspirations to be able to decarbonize the national gas network up to about 20 or 30% by feeding in hydrogen, and that's known, and that's been sort of proved to be feasible and safe and manageable, because basically it doesn't create the need to do any burner changeovers or technology changeovers really. So it's, in that sense, it's analogous to the fact that most of our petrol now is 10% ethanol rather than all fossil. Anything above that 20-30% levels, you do start to need some changes in burner setups or controls, in pressure controls and in safety strategies as well, for particularly for safe ventilation. We've spent quite a lot of time this year at the Institute doing the risk assessments on ventilation and where we are currently allowed to site hydrogen pipe runs and so on, as we try and invest in a network, a small network of hydrogen for the site, so we can do the innovation we want to. But yeah, as a very light, very mobile gas which can leak through many materials. It has its own set of issues and problems to deal with. Where it is appropriate for many users is still and still has the edge on electricity, or is certainly in undisputable competition with electricity, is where you got to deliver large quantities of heat, or high temperature heat quickly. So a steel rolling mill would be the ideal example there, or similar processes where there's a need for controllable, dispatchable, high temperature flame. I mean, hydrogen will burn up to 2000 plus. So you actually get a hotter flame than you get with natural gas, or with a natural gas kind of coal gas mix or whatever these things were set up for originally. So there's changes to be made. It's different. It's a different flame, but it's still compatible with most of the processes which are anticipating a combination of convection and radiation and so on from a flame-driven heating system. And in that sense, it's familiar, and it makes sense to transition and think about how would I get my furnaces over to a hydrogen mix, or eventually look at going 100% hydrogen if I can reliably source the stuff. because it's this, you're still burning a gas to heat the material or melt the material ready for processing. With that in mind, we're seeing I don't know, I haven't got the numbers, but certainly a balance between customers in the metal sector who are thinking, how do I prepare for hydrogen transition to meet my carbon reduction targets, and those of my customers, and others saying, how do we don't think hydrogen is actually going to work on our particular location, or we think it would actually be overall more efficient to be moving to electricity. How do we electrify all these heating processes? So that's part of the transitional element to it. Still disruptive because it changes the way you have to operate, and some of the issues of supply and procurement and so on. But the more disruptive element of hydrogen, certainly what we're involved with, is looking at it as a reductant, as a chemical agent rather than necessarily as a heat source. So this is the driving force between most of the headlines around green steel, is that it can be made with hydrogen as the reductant rather than coal or natural gas, and then that is then married up to whatever approaches you want to use to actually melt the stuff down and turn it into steel, which I'll leave it at there because that's a whole other set of lectures and conversations. But this is the area where, in terms of disruption and in terms of competition, there isn't another clear front runner really, other than saying we want to go down the hydrogen route, or we want to use more hydrogen as in the reduction of iron ore and other ores as well. It attracts the headlines. It is still quite an unfamiliar technology, though. I'll say that it is still at pilot stage around the world, and although there have been in the last 12 months even several announcements, particularly around Europe, about strategic plans to transition steelmaking to a model which has a green hydrogen electric based iron production to then feed into the steel making. Most of those strategies also still have a backup of using natural gas as a reductant, where, similar to this kind of tower on the picture here, you're basically blowing direct reduction of iron. For those not familiar with the concept, you're basically blowing gases through a hot column of iron ore, and the reduction is occurring at the solid phase. So you end up with solid metallized sponge iron, essentially, which you can then briquette and melt. You can put it in a BOF furnace. You can put it in an electric arc furnace, which is kind of twinned up with the hydrogen iron making in most of the sort of assumptions about how will iron and steel evolve going down the line. And at the institute, this is part of the mix that we're investigating in terms of investment and developing reduction furnaces or reduction vessels at pilot size, which we can then integrate with our own electric melting pilot facilities. And this is part of our sort of plans and ambitions to be working with partners around the country and Europe and elsewhere, really to make sure we have some accessible facilities that we can start to demystify some of the issues around hydrogen iron making. but it is a disruptive technology. It's one of those things where all of a sudden the creation of iron units into the market, which is still going to be needed to even with increased steel recycling, there is still a feed-in of clean iron units will be needed if we maintain the expected levels of demand for steel. Will accelerate faster than the resupply of scrap for several decades more. That's the way the models look at the moment. Obviously, if you want to reduce demand, stop buying so many things, stop making. Okay, I'm not going to get myself in too much trouble by telling people to stop making things, but you know that is part of the solution, isn't it? The transition to a differently modeled, a differently registered economy, and part of that disruption is the fact that I could, if I had the money in my back pocket, I could turn up on Redcar Beach tomorrow, plug myself into those wind turbines out there, buy a stack of iron ore and start making iron, and then just sell it to a steelworks. That's being slightly flippant about it, but it's entirely possible that the next movers and the disruptors in terms of the supply of green iron into the global materials market will not be necessarily the traditional steel makers, because it could be energy companies, it could be the ore producers themselves. A lot of interest in that. I mean, yeah, a lot of interest, because why wouldn't you? If you can generate hydrogen, you don't have to source coal and make iron locally. And the fact that it's a solid to solid transition means providing you are providing you're making the product safe at the end of the process, because it is a very high surface area metallic iron product, so it's potentially hydrofluoric. But providing you are making it safe at the end of the process, you could start creating the iron in different parts of the world. Again, it's one of those elements that could potentially redraw the map. So that's another thing that sort of informs our perspective on how to help accelerate the decarbonisation of metals processing. The fact that new actors have a chance to get involved at this stage, there's those potential new partnerships, as well as not ignoring the fact that the existing large-scale steelmakers, other ore producers, other producers of other metals and so on as well, will also be looking at how they decarbonize their existing processes. And I've put a bullet point on the bottom there, because part of the transition to however the economy looks in the future, a large strand of concern in there is around that being just and fair. In other words, I don't have to tell anybody on this call probably, we know what happens when major industries in a traditional manufacturing area get shut down. We know what it looks like, and it's not pretty. And that has got to be part of the political settlement around how resources and use of energy and reconfiguration of the economy for the future develops, really. Okay. I'm not far off the end, but I just wanted to share back of the envelope just for some scale. And this is based on numbers from a couple of years ago, so it's not pinpoint accurate. But if you wanted to just decarbonize steelmaking by going down a hydrogen electric route, or by going down a hydrogen route instead of coal for iron making, just say, why don't we just do that? You know, there's your big tick. There's your emissions reduction for the year. Why don't you just make it with hydrogen? Not as easy as it sounds. And one of the reasons behind that is you would need more hydrogen than we currently make in the country anyway. And you would also, the increase in electrical demand is equivalent. Well, you can debate the numbers, but the bottom line is we came up with a figure of about 6.5 million households. So it's equivalent to a couple of large cities worth of electricity. It's not a small amount, because there, as we know, the energy intensity of fossil fuels, and coal in particular, is what's driven and maintained the industrial revolution up to the present day, basically. So it is a not at all insignificant amount, and this has to be part of the conversation. The realization that you've got a 1 or 2 orders of magnitude of increase if you're going to be transporting large amounts of electricity to different places to power processes, to produce hydrogen locally, and so on. It is interesting, actually. I would have said a year ago, I would have said, from conversations with kind of steel making in Sheffield, in central England, that they were feeling like they may be kind of behind the curve in terms of investment in sort of net zero production and so on, because of lack of access to hydrogen from offshore generation, or from existing hydrogen industrial hubs and things which have been announced. And yet one of the UK's major electrolysis manufacturers is based in Rotherham, in the Don Valley, basically, and is producing and ramping up production massively for electrolysis, part of which informs a vision of producing hydrogen locally in Sheffield and Rotherham for industrial use. Whereas they would never be able to plug into a national grid of hydrogen pipes for another 20 or 30 years if they were going to wait for it to be pumped in from Teesside or from Humberside or wherever to them. So the grid, the energy demand grid gets changed, gets molded and formed into different shapes, and you have peaks, and the nodes of high energy input and production change as well, and that's also part of what a joined up industrial evolution strategy has to look at, really, is getting the actors all talking together so that the infrastructure can handle the transitions. And again, that it adds extra costs, it adds extra materials. It's not without cost. So again, the national conversations around the overall impact on carbon dioxide levels in the air, or greenhouse gas, more to the point, levels in the air, has got to be had as intelligently as possible. Okay. I'm going to move on and give some time for chats and questions, because I've already sort of intimated it. Some of the work that we're doing in Eston, or wherever you want to describe the location of the institute as, just around the back of South Bank train station. But really to invest in the bits of pilot furnace for heating, and the bits of pilot reduction equipment for green iron making, and linking that into green steel making, but also getting enough hydrogen usability that other people who are innovating in the space, who want to look at hydrogen electrolysis and lower energy ways of producing hydrogen. I mean, Teesside University, for example, quite a lot of work on electrolysis membranes and other processes like this, just to pick a local name out of the air, but also a lot of more established energy producers in the area. There is a lot of innovation, there's a lot of ingenuity locally and nationally as well, but giving some space and giving some of the enabling framework that lets the innovation happen, lets people get their ideas up to the next phase, particularly now when there's so much kind of interest and attention and potential interest in investment and technology development going on around sustainable hydrogen. It's almost too much going on to keep track of everything. But it's certainly an interesting, whether you want to be alive in interesting times or not, it's certainly an interesting time to be anticipating and trying to do our bit really to make the most of the potential role of hydrogen in transforming, disrupting and changing and ultimately creating a more sustainable and much less carbon intensive industrial cycle and processes for people. So I'm gonna leave it there. I haven't been able to see the questions, but if I close my slides, I think I'll then be able to see all the chats and that kind of thing. Thank you.
Thank you, Mark. The usual thing we do is I sort of read out most of what's in the chat. It seems to me, I've been keeping an eye on it, more comments than than actual questions. Alan Scholes says, much of the world still thinks we can hit CO2 goals with minimal disruption and still expect a world with cheap energy. In that context, hydrogen gets bundled in the too expensive box. How do we wake people up to the reality that energy is underpriced in relation to its societal value and accept that this has to end? I don't know whether you've a comment or an answer to that, Mark.
Anybody else got any ideas?
Yeah, if you want to speak, you'll need to unmute yourselves either by pressing your space bar and holding it down, or there's a mute, unmute, or there should be a mute, unmute button somewhere in the band at the bottom.
While people are plucking up the brain power to respond to that question, I mean, I would, part of what I'm trying to do today and in similar kind of conversations is to make sure that we bundle those the implications of the choices we're making in with the sort of excitement around the technical possibilities of it, to make sure that we're talking big picture and keeping our eye on the actual goal of trying to reduce the rate of increase of greenhouse gases.
David Routledge wants to make a comment. Over to you, David.
This was a question which has been. Can you hear me okay, by the way?
Yes.
Yeah.
Yes, fantastic. That's a question which has been on my mind for a while on this subject, which hopefully someone here can answer. Once you put all the hydrogen into the iron to get your iron ore, how do you get all the hydrogen back out again to get steel, which isn't chock full of hydrogen?
Two answers to that. One is we're working on it.
Okay.
The other is most of it comes out as water vapor, and or dissipates out. But the short answer on it is that that's one of the things that we're working on. That's one of the reasons we actually want to develop our capacity to make green iron on site and be able to investigate it and play with it, because it's not just the iron, it's also the question of where's the carbon going to come from. That's what the steel makers actually want to know. If you've not got any carbon mixed in with it to start with, if you're not using coal anymore, where are you going to get your carbon units to turn it into whatever grade of steel you want, and to play with the temperatures and so on?
Okay. So essentially you oxygen lance most of the hydrogen out, as you would get rid of most of your carbon from the traditional process, and then you try and
possibly. Honestly, come back and ask me a year from now.
I will. Thank you.
You can come over and see it in action.
Thank you.
Hopefully.
The next comment stroke question was from Johan van Boggelen in the Netherlands, who's I think you're manager of the Hisana plant now, aren't you, Johan? He says, in the global net zero in 2050 scenario from the IEA, the view for the steel, and I've lost that, the view, sorry, I seem to have scrolled up or down, is only on a very small space, this. Beg your pardon. In the global net zero in 2050 scenario from the IEA, the view from the steel and other energy intensive industries is that they will still be heavily dependent on fossil energy carriers with CCU/S. I'm not sure what that is. Their view seems to be that green electricity and hydrogen will first be used to support the energy transition in other areas. What is your view on this?
Okay, Johan, thank you. And thank you for your next comment as well. My personal view is that CCUS is not going to be as much of a magic bullet that people are expecting it to be. Particularly, a lot of policies are predicated on the success of it. I think it may be it hasn't yet been proven at scale, like many other technologies.
Pardon my ignorance, but what's CCU?
So CCUS being carbon capture, and if it's CCU, carbon capture and use, so reuse, or carbon capture and storage.
Right, sorry, I should have known that.
Generally implying sort of pumping it back out into oil-bearing rocks to push out more fossil energy, which is the other kind of question there. It's a personal view. I would rather forge ahead and also be making the case to say you have to prioritize the highest carbon gains that you and the areas where hydrogen is not really easily replaceable, and to be continually pushing for that as well, and saying I'd rather have electric vehicles, fewer of them, more public transport, and green iron than everybody driving a hydrogen car, for example. That's anybody want to come back and give a completely different perspective on things there?
I can come back on that myself, actually, and I agree with the comment Ken Grijmek makes later on as well, where in the end it's just we just have to do it, really. But the situation is, of course, that you can only use that electricity once, and if you really look at it, direct use of the electricity is the most efficient way of doing that. So actually replacing all the electrical stuff we have now with green electricity would give you the highest efficiency of the green electricity. But that would not make you any hydrogen. That would just charge a Tesla and the local the new buses and drive your trains and I don't know what. So we need a way to make more of that electricity fast. And one of the next comments I make is actually about getting that green electricity. Here in Holland, the energy companies are basically complaining that it's all good and well that you want us to build all these wind farms, but it takes us 8 years of permitting and planning before we're even allowed to put one wind turbine out at sea. And it would take us 2 years to build a farm. So the proportions are all wrong. And I think there is a lot more clever decision making from politicians necessary that can think further ahead than just their own term in government, and they are rare, particularly if they're very busy having parties. But
business meetings, you mean, John?
but I think that is actually a genuine problem. That's the people who make the policies. It's more like a popularity contest for what's happening in the next 2 or 3 years, instead of thinking ahead what's going to happen to the world in 30 years' time.
It's a case of however we phrase it, ecological literacy or environmental literacy within the people who make or take the big political level calls on which bits of policy to support and for how long. It's a perpetual frustration of mine the short-termism of most of the kind of various trends and fashions of energy and sort of environmental improvement stuff that comes along, and you get it enough to get some interest in it, then where you should have had a 10-year program, it just turns out to be a 2-year program, and then it's yeah.
Yeah, I agree, Mark. I made a few comments about hydrogen investment, and the biggest trick is as always is funding, being able to find funding that is able to be used anywhere, because most of the governments are only wanting to either do it in their own backyard, or, as Johan said, not to do it in their own backyard because they don't want to have windmills whizzing around in the back garden. So they want the green renewable energy. They don't want to pay for it. And if they do want to pay for it, they want to make sure that your money is only invested in their own little area. So if you want to set up a massive solar power station, or power station in the Sahara Desert, which would be ideal, and make hydrogen there, which also would be ideal, and then transport it to the rest of the world, nobody would invest in it except for Tunisia, and they are obviously not capable of doing so. But Europe is just sitting on its hands in order to hope that somebody else will do it. And the industry is not going to pay for it because they will immediately be uncompetitive with those countries who don't have to make the investment. I had a discussion today with Boston Consulting Group in Russia, who are saying, well, you know, what do we do? I said, well, you've got abundant amounts of natural gas, very, very cheap. So you will never make green electricity because you're just going to burn the natural gas, because everybody will plumb for that. And that will allow you to make blue hydrogen if you want to use CCS, and that's probably the best option in the meantime. But from an investment point of view, it doesn't make sense. If you want to make green hydrogen, you need to use renewables. You need to invest directly in that. Otherwise, you have to make the investment twice.
Mm-hmm.
So it's a question of, you know, chicken or the egg. And yes, politicians are only life cycle of a politician is 3 to 5 years at best. So that's as far as they see.
Yeah, I think picking up on that point that Johan made and that Henrik's just made, we've just had a brilliant illustration of this over the last couple of days in the UK, that it is perfectly obvious that moving to hydrogen technologies or even the various green electricity technologies has a cost, and we will have to get used in the long term to the fact that our energy is going to cost more, and actually that's going to be one of the drivers that helps us be more efficient. And yet, faced with the recent increase in gas costs, not one of the UK politicians in the debate that we've just had has had the courage to actually say that. They're all looking at ways to continue to subsidise the cost of energy to the consumer, and in relation to what its value really is and has to be in the future, we're going to have to get used to the fact that it costs more, and politicians are still not sufficiently engaged to be willing to say that, outside of pressure groups like the Green Party that don't have enough political clout to actually get unpalatable messages like that across.
You're right, Allan. I mean, it's the unpalatable message. I mean, we've it's not been mentioned in all the debate about what we do about electricity prices. As you say, it's all about removing the levies, but no mention of the consequences of that in relation to carbon, which is it is potentially a missed opportunity. But I suspect you can understand why the politicians won't do it. It would be suicide from their perspective in the election cycle.
Yes.
Well,
You
currently, but it, you know, expectations of the electorates can and do change over time as well. But yeah. again, it does come. Sorry, Sue, you're trying to draw things to some order, I think.
Well, I was just going to move on to Johan's next comment, which was to say that 100% hydrogen iron ore reduction is still at pilot scale, but one of the big equipment manufacturers, I think Tenova, claim they can add up to 70% hydrogen in the DRI shaft. Johan then posts a website which I have copied into a document. So if anybody wants it, that website, please get in touch with me and I can send it to you. You don't have to squint at it and try and scribble it down.
Yeah, and these questions in general would be certainly useful for me to look back. I see one of Hank's sort of later comments as well, asking why would we want to kind of reinvent the wheel. What we're attempting to do is not reinvent the wheel. It's acknowledge the fact that it's been demonstrated you can. There's no question. Can you reduce iron with hydrogen? There's a lot of questions about how would you do it. There's certainly questions about what happens if you're not using any carbon in the mix, and is that ever going to be a good idea? And also the questions about how do we get hold of some stuff to work out if it works in our process. So what I'm actually focused on is trying to mirror and have a range of reducibilities on site, so that we can make accessible some of the next sets of sort of R&D questions that people need to be developing the steel making, and sort of plugging in, so that, because we're never going to start our own steel company, but we strategically are trying and tactically are trying to find where's the point that's currently palatable and affordable within the UK innovation context to create facilities to move things along, to hurry things along and answer questions that people will need to answer about the final product that they've got to sell, rather than just saying, oh well, okay, we're just going to be beaten to the draw by the Swedes or whoever. One day down the line, any steel and iron that's still being made will be made on a net zero process, whatever that is. So it's a case of doing what we can with the resources we've got to move that along. And part of that is making sure there's accessibility to some of these technologies, so that we can. It's about education and informing, and showing what the potential for things are. I think that is also going to be a key part of the sort of the evolution of a more sustainable sort of industrial economy. You can tell I'm a child of the 80s. The perestroika, the reconstruction, and the glasnost, the openness, the Gorbachev were his hallmarks when he looked to reform the Soviet political system. But it actually, those two elements actually play in quite a lot to how we need to, in my view, think about the evolution and the accelerating the evolution of our current industrial economy to something much more sort of sustainable and fairer, because the alternative is basically catastrophic crash.
Joe wants to make a comment.
I'll get off the soapbox again. Let some other people talk.
Joe wants to make a comment. Over to you, Joe.
Thanks, Sue. And that was really interesting, Mark. I think I was just thinking about the politics side. I mean, one thing I would say is, looking at some of the approach to hydrogen, I think, Tees Valley Unlimited, I think locally in terms of the politics, I think with the mayor, and I think we've seen with sort of local political actors, just in terms of some of the advocacy in Parliament, like, I mean, Jacob Young, the MP for Redcar, is chair of the all-party group on hydrogen. His Labour predecessor, Anna Turley, did the same while she was in Parliament. And I think one of my big frustrations is actually, on Teesside, there's been a big push on hydrogen, and there's a better understanding. And I think locally with Combined Authority, sort of the invite with officials from Whitehall to come and see the range of industrial producers and set out the ambition that there is locally for moving this. Unfortunately, there was a very clear message from officials back in 2018, which said, our question to you is why now? You know, elsewhere, as you just mentioned Sweden. I mean, you know, we look at China. In the same month that officials from Whitehall came and said why now, the Australian chief scientific advisor was saying why now, but without the question mark. You know, so I mean, Whitehall has dragged its feet. Unfortunately, it's done continual reviews. We do finally have a hydrogen strategy, but we are 3 years, at least 3 years back from where we should be on this, and people are getting on with it. And so, you know, I think there are very good questions. Allan raises very good questions about the energy side, but you know, on the innovation side and where government is permitting, then you know, I think I actually see sort of Kwasi Kwarteng, the business secretary now, Claire Perry, the former minister, pushing this harder than some of foot dragging amongst bureaucrats, which is really frustrating, frankly.
And another thing that occurs to me is really we need to all be doing this together. I was a bit surprised that the website that Johan circulated was somebody Chinese, because they've done precious little in terms of environmental concerns at the moment. I actually went to China in 2007, and I was absolutely appalled at the state of the place. You know, their idea of disposing of waste is just chuck it in the nearest river or chuck it over the wall. And as long as you've got anybody taking that sort of attitude, those of us who are more responsible, who want to reduce greenhouse gases, really we're spitting in the wind if you've got other people like China and India and goodness knows where who can't be bothered or can't afford it, or there's some other reason. I know that's not a reason why we shouldn't try, but it just makes it more difficult for us, because if we do make green steel, it's going to be more expensive than non-green steel made in China. You know, and just look at all your domestic appliances. Most of them, I dare say, will be made in China, whether you're aware of it or not. It's very difficult to buy anything that's not. And I don't know how we get over that problem.
Well, I think your 2007 visit to China has been superseded a little bit with their technologies. Following the Olympics in 2008, they already made significant changes, and also the last 4 years they've introduced a provincial ETS scheme to curtail the carbon emissions, and the government does not muck around. Companies get 12 to 18 months to fix problems, and if they don't fix the problem, then the CEO of that company no longer works there. In fact, he's behind bars. So that usually incentivizes them significantly in order to make the investment very, very promptly, and they do.
Oh, I'm pleased about that.
And they achieve it as well. I've seen basically all the emissions, apart from CO2 in the steel industry, can be managed technically to less than the World Health Organization limits without a problem, and that's available off the shelf now. So there's no excuse for any organization who says they can't do it. It's a question of actually buying something, installing it, and make it work. Same as you make steel work. So the Chinese have moved significantly ahead. Their companies are consolidating. There's very few companies now less than 50 million tons and reaching near 100 million tons. And they are making the investment because they are quite large, and of course they've got unlimited finance available, which we've given them, by the way, by buying their goods. So they have to pay it back at some point, but of course they've got better financial systems than we have, and they're not broken up. If you've got 1 billion tons of production with 1.3 billion tons of capacity, it does give you a bit of clout with the government to say, look, we need some more funds to make it work, and they will. I think within the next couple of years, they will, before 2025, they will be significantly reducing their carbon emissions. The hydrogen DRI EAF units are being built by Hebei and in the Hebei province, just east of Beijing. And they're building one pilot unit now, 2.5 million tons. And they're likely to build multiple more of those. The Arvedi system with EAF coupled directly to a hot rolling mill, they've built 5 of those. So coming back to the European plants, they are ancient compared to the Chinese ones.
Well, I'm very pleased to hear that. It's obviously been a complete turnaround since I was there.
Mm-hmm.
Chris Barnes asks a question here. He says, is it realistic to think that Europe will be importing millions of tons of ore and exporting / dumping millions of tons of scrap?
Steel making dudes, what do you think about that?
Well, if we look at it in today's context, you'd have to say, yes, it is realistic because that's what we're doing.
That's what we do now.
In terms of how we need to develop, then clearly that isn't the situation that that we would like to persist in the future. So yes, I mean Chris's point is I guess we have to, and we are working towards looking at how we can transition to a position where we use all our arising scrap and turn it back into products. And for the non-steel makers in the audience, the problem, of course, is that scrap comes with contaminants, which means that whilst you can make the majority of steel making of steel products successfully from a scrap-based feedstock, you can't make the higher quality ones without some significant changes. And you know, Mark was saying what we're doing with hydrogen, but some of the other things that we're doing in the institute is looking at how to address some of those challenges. How to get nitrogen out of steel by a scrap-based melting route to levels equivalent to the ore-based melting routes is one of our projects. But yes, it doesn't look clever and it doesn't look sustainable when we're exporting a tonnage of scrap every year equivalent to the tonnage of virgin iron ore raw materials we're bringing in. But the problem in the UK particularly, but also in other parts of Europe, is that our energy prices, if you go down the electrical melting route, are not competitive with the conversion costs going down a carbothermic reduction route. And that's another of the big technical challenges.
Thank you, Alan. Quite a few of the comments and questions were from Henk and Johan. Do you two think that we've actually covered most of your points, or are there any that we've missed rather than me read it all out again?
I think most of my points have been made and discussed.
I think Henk's actually left us. Right, well, it's 7:20, so I think all it remains for me to do then is to thank Mark very much for initially presenting us the talk and then provoking quite an interesting discussion. If anybody, I will actually copy all the questions and comments out of the chat box into a document. If anybody would like them, please email me. I'm assuming that everybody has via some means or other access to send me things. And if anybody wants to make any further points, maybe we can stick some of them in the next newsletter. I see 1 or 2 people have discovered the clapping icon. Thank you very much. I think that's probably just about all. So it only remains for me to say thank you and good night, unless anybody else wants to say anything.
I'll just say thank you all as well for staying online and participating, and do get in touch if you want to follow up extra questions. As Sue says, there's plenty more we can.
Yeah, thank you. Thanks, Mark. Thanks, Sue.
Bye, everyone.
Yeah, cheerio, everybody.